Hi Neil and Aaron. I'm Angela Hurman, and the WebQuest I am designing is targeted at senior biology students. The WebQuest is actually based on a marine biology unit undertaken by Year 12 students at a local high school. However, because of the way that Queensland senior syllabus is structured, it could also be undertaken by Year 11 students. In either case, it is expected that students undertaking the WebQuest have a good understanding of the topic ecology. Specifically, students should already know that ecosystems are made up of living organisms and their physical environment, that living things have processes that enable them to adapt to suit their environment, that many factors, both biotic and abiotic, influence the size, composition, and growth of communities and ecosystems, and that many factors, including human influences, have an impact on and can change the environment. Students should also have had some exposure to or experience in collecting environmental data in the field. In the WebQuest, students will assume the role of marine biologist and environmental consultant. They will select a site on the Great Barrier Reef where development is fictitiously proposed, and their task will be to prepare an environmental survey report. The report will be required to give an objective assessment of the value of the site in terms of the biodiversity, and the students will need to make recommendations regarding the proposed development. The assessment and recommendations must be supported and justified by data collected by the students in their WebQuest. The best way to run you through the idea of the WebQuest and the different types of ICTs that will be used is to run you through a bit of a flowchart of the WebQuest. So, starting at the top left of your screen, you will notice the WebQuest begins as a team project. Students will be given an introduction to the topic, and they will have a number of sites and development scenarios to choose from. From here, they conduct some background research using pre-selected websites and video links, and then select and map their chosen sites using Google Earth and imported spatial data layers. Once this step is complete, students then have the opportunity to conduct a virtual dive or tour of their selected location. A number of research projects are underway at the moment which utilize live video streaming of the reef, and there is also stored data on the Catlin Seaview website which allows for virtual dives. Some screenshots from this website are what are displaying on your screens now. The idea behind this part of the WebQuest is that students are undertaking a site inspection to obtain amenity and aesthetic data on the location, and they are also determining what data they will need to collect to make their assessment based on the habitat they see. Once students know what data needs to be collected, they will use the internet to research the methodologies marine scientists actually use and create their own sampling design. This step is denoted by the design survey method on the flowchart. You will also notice it is after the stage where students can divide up and allocate specific roles to research. For example, fish biologist, coral biologist, and so forth. This step has been put after the sampling design so all students are exposed to each aspect. However, they could separate earlier and collate the sampling design later if that suited the learners better. The actual collection of the data will utilize various technologies depending on what site is chosen. At a minimum, however, students will find and use real-time temperature and climate data transmitted from satellites and marine monitoring stations, as well as real water quality data. They will also view real-life footage taken of their location, and they will analyze screenshots from this footage to classify species. The results obtained from their data collection will be graphed and tabulated, predominantly using Microsoft software, and students will independently analyze their results, devise a hypothesis, and make recommendations supported using their data and further research. This is how the problem posed by the WebQuest involves the students in higher order thinking. Students must make links between the biodiversity data they have collected and the potential implications to this biodiversity if the proposed development of the site were to proceed. They must design their own methodology, collect and organize data and identify trends, as well as critically analyze the data and use their judgment to make links to the site's ecological value. Students must also fully justify their recommendations based on their data and research they have collected and conducted. Essentially, what the WebQuest does is take students through the entire process of conducting a marine field trip and writing the subsequent environment report without ever having to go in the field. This is actually where the idea of the WebQuest stems from, and also links to both the design thinking framework and the equity issues that have been considered in the planning of the WebQuest. Being able to conduct a real marine survey as part of a school program is a rare privilege which is dependent on the school's location and the cost of the excursion. Those students in rural or remote areas may not have access to the marine environment, and those students from lower socioeconomic backgrounds may not be able to afford the additional costs. This web quest is therefore intended to make this learning experience possible for everyone by recreating the work in an online multimedia fashion. Conducting the work in this way is actually not unlike what real environmental consultants and marine scientists often have to do in the early stages of projects due to financial or time constraints. Further to this, the web quest makes the most of real existing scientific data. By doing so, it does not require transporting a boatload of people out into the field, and consequently, the carbon footprint of the activity is reduced. Additionally, for the collection of data, students assume specific and separate roles and then share and collate it with their team at the end. Thus, by working cooperatively, power usage, downloads, and carbon emissions are reduced further. Well, that just about sums up my planned web quest. I look forward to bringing you the final version and looking forward to hearing any feedback you have on the planning so far.